AP Statistics final project.
So our game was Crazy Toss, and the game has a 5x5 layout of cutout holes where pickleball was tossed from 4 feet away. We need a table to set up our project on with a cardboard cutout that is raised with cups to make sure the balls don't bounce out. We also need space of a distance between the player and the board. The material is red cups because they are very practical, lightweight, easy to arrange, and visually distinct, making them ideal targets for the ball toss game. The stability and durability of the cups were arranged in a way to keep them stable and durable enough to withstand repeated ball tosses without tipping over easily. On the left is a depiction of our game, and you can see the aerial view and the frontal view. And the rules of the game were that the player will receive 3 pickleballs after paying entrance tickets to play. They will then toss the balls one by one until they have none left. Ticket values are randomly assigned with the colors to the holes, and what the player will receive is based on what they land.
Probabilities. Our game will be successful because there are enough spots where there's a chance of winning or having all of your throws not result in a DQ. We made it so that there were holes that rewarded a generous amount of tickets with a low cost to entice players to participate. We also made it so there were more slots for getting disqualified, which increases the chances of us winning instead of the players. We made it slightly off balance with the probabilities, where there are 4 out of 25 slots of getting disqualified and 21 out of 25 slots of not losing, which attracts players as they see that there's a lower chance of losing than winning. Also, with the fact that the probability of scoring any points is low, it will result in a loss of tickets when you take into account the cost to play the game. The probability of earning 3 points is extremely low. On the left, we have the math for each, the probability of 0 points, the probability of being DQ'd, and the probability of getting points.
For the experiment, we intended to gain attraction by having a member of our group dressed as a hot dog. And then we used the results of the survey to compare to see which if our game did better with the costume member or without. And after the survey, the results showed that there were a greater number of people, 44 to be exact, that chose to attend the game if there was a person dressed as a costume versus the 23 people who said they didn't want to attend the game if there was no costume. And then based on the results, we can assume that having a person dressed up in a costume will bring more attraction and more players to our game. And then on the left, there's a graph that shows the results from our survey. And you can see the 23 people who preferred no costume versus the 44 people who did.
So for our carnival game, we also introduced a spinning version, and the rationale for this change was that the addition of the spinning cups was a strategic enhancement to make the game more challenging and interesting. This change was driven by several factors. Firstly, it was increased difficulty. The spinning mechanism made it harder to land the ping pong ball in the cup with a chip, increasing the challenge and potentially making the game more engaging for players seeking a more difficult task. The higher take costs because we could justify charging 6 tickets instead of 3 with a more complex version of the game. And this not only made the game more premium, but also offered players a choice, catering to both casual and more competitive participants. The extended playtime through the spinning motion prolonged the gameplay, making it more of an event and drawing more spectators who might later become players.
Carnival Gate continued. Ticket pricing and revenue strategy. In the normal version, the tickets were priced at it was priced at 3 tickets per each. This setup was affordable and encouraged many players to try the game, contributing to a steady stream of revenue. In the spinning version, it was more challenging and visually exciting, and it cost 6 tickets per game. This higher price point was justified by the added strategy and entertainment value, attracting players willing to pay more for a unique experience. In the revenue generated, there were a total of 583 tickets generated by our game, and out of the total, only 3 tickets were given out as prizes. We had a lower win rate, which is due to the increased difficulty with the spinning version or the strategic placement of the chips in the cups. And with the low prize distribution, this game successfully maximized revenue while minimizing payouts. In consumer engagement and revenue analysis, the difference in ticket costs between the normal and spinning versions allowed us to cater to a wider range of players and increased overall participation. And by analyzing how many players opted for the spinning version versus the normal version, we could gain insights into customer preferences.
For our hypothesis test for the first one, our question was, does dressing a team member in a hot dog costume increase the number of people who chose to play the game? The data is in this table. on the left, and our null hypothesis was that the proportion of people who chose to play the game is the same whether or not a team member is dressed in a hot dog costume, versus our alternative hypothesis, which was the proportion of people who chose to play the game is higher when a team member is dressed in a hot dog costume. With our sample data, 44 people chose to play the game with the costume versus 23 people who chose the game without the costume, and there was a total survey of 67 people. Probability of people of costume is 44 over 67 versus the probability of no costume is 23 over 67. And the variables that could have affected the experiment were the time of the day, the visibility of the game from different angles, and any other competing attractions that could influence the number of people.
So for our two proportion z-test, on the left we can see that the proportion of people choosing the game with and without the costume on the histogram, and on the right we have their calculations which came to a p-value of 0.111, which is greater than the alpha value. So we failed to reject the null hypothesis. There's not enough evidence to conclude that dressing the team member in a hot dog costume significantly increases the number of people who choose to play the game.
And our hypothesis test number 2, our question was, does the version of the game significantly change the revenue earned? And we had a null hypothesis, which they equal, and our alternative hypothesis where normal was less than spinning. The procedure was that we would perform a two-sample t-test to compare the average revenue per play between the two versions. The data provided was that the normal version was 3 tickets per game, spinning version was 6 tickets per game. Total tickets earned 583, number of plays were assumed, and normal equals 100, spinning equals 50.
For our second hypothesis test, which was a two-sample t-test, you could see that based on the t results, the p-value was less than a, so you would reject the null hypothesis and conclude that the spinning version generates significantly more revenue than the normal version, and the graph on the left shows our data.
So for our hypothesis test number 3, our question was, is the observed win rate significantly different from the expected win rate based on the game design? And our null hypothesis was the observed win rate is equal to the expected win rate of landing in a winning slot. And the alternative hypothesis was the observed win rate is not equal to the expected win rate. And on the left, we have our data, which comes to winning slots being 21 out of 25, 0.84%. And disqualification is 16%. So sample data, when we observed 200 plays, 150 losses and 150 wins and 50 losses, the lurking variables were the skill level of players, randomness of hole assignments, possible biases of ball tossing method, and these could all affect the actual win rate.
And for hypothesis test number 3, one sample t-test, based on the calculated p-value, we would reject the null hypothesis, and this would indicate that the observed win rate significantly differs from the expected win rate based on the game's design. Thank you.
Thank you.